All right, good morning, folks. So today we're going to talk about while loops. Before we get into the lecture, I want to mention a couple things that are coming up. So your PA2 is due on Thursday, end of day. Of course, you can come to my office hours today after class or Thursday after class. And then also, of course, there is the tutoring sessions on Thursday as well. So since the homework isn't due until the end of the day, you could certainly go to the tutoring sessions as well if you want some additional help. In my email that I sent out yesterday about sort of the weekly update stuff, I mentioned that we'll be having our first exam next week. So that's the week 5 exam. So we'll have one in week 5, somewhere around week 10, and then during finals week. So sort of 3 exams spread out during the semester. So what we're going to do on Thursday is the review for that exam. It will be completely on Blackboard, but we will do it during class next Tuesday. So essentially, what'll happen is we'll come to class like normal. I will sort of open up the exam to be taken. There's essentially a time limit on it, so you can't sort of spend the rest of the day working on it. So I'll set that up. I'll talk about it a little bit beforehand. If we were actually like in class, I would typically hand out the exam and then sort of talk about each of the problems. So I'll do something similar to that when we actually have the exam next week. During the review, it's basically just a bunch of example type stuff. So on Thursday, we'll do some of that, basically a full day of sort of examples, exercises, so you know what to expect. I'll also give you the overview of the topics and stuff like that. So we'll talk about that stuff on Thursday. We'll have the exam next Tuesday. And then we'll get back to sort of the regular lectures after that. So today is the sort of last sort of lecture before our exam, last sort of actual lecture. So today is about while loops. So we've done sort of the basic variable stuff, reading things in, printing things out. We looked at some if statements, so some conditionals to help us control what our program actually executes, depending on things like maybe a number that I typed in. Loops are another one of these control flow ideas. We can control what our program does based on another structure. So similar to our sort of if-else structure, we're going to have this while loop structure. So the reason why you would use a loop is that oftentimes you need to repeat or compute the same sort of action many, many times. There might be a whole group of steps that you have to do many times. There might be a single step you have to do many times. I want you to think of it like this. When you're playing a video game, for example, every single frame, between every frame, there's a whole bunch of logic that happens. There's checking for input, whether you clicked a mouse button or pressed on the keyboard. There's all sorts of AI stuff being calculated. The graphics and stuff are changing between every single frame. All of those actions have to happen between every single frame. So essentially, you have a game loop, a loop that's happening every single frame during your game. So this is the idea of why you would need loops. You have to compute AI every single frame. You have to compute what graphics should be on the screen. You have to get input every single frame. So this is the idea. This is why we need to repeat certain calculations or certain actions many, many times throughout the life of a program that you're running. So, for example, as sort of a simple thing, maybe you want to print to the screen, I will not expose the ignorance of the faculty many times, 100 times. So Bart here writing on the chalkboard, maybe you want to have that in your console. With what we know right now, with just the stuff we've covered in class, you could use 100 printf statements. It's a lot of copy and paste work. And if you wanted to change what the message says each time you print it out, you potentially could sort of come up with sort of errors in your program where you accidentally didn't change something, or you changed one and it's not correct, something like that. Whenever you find yourself when you're programming copying and pasting a lot, there's usually a better way to do it. And this theme of sort of copy and pasting being sort of wasteful will come up over and over again. There's lots of different things in in programming, lots of different structures and concepts in programming that will reduce that amount of work. So even if you don't know how to fix whatever it is you're copying and pasting to make it sort of work a little bit better or use a different construct, just know that there is likely something that you can do to make less work for yourself and less potential for error. So we definitely don't want to use 100 printf statements. So instead, programming languages have these mechanisms called loops. We're going to talk about the while loop today. There are other types of loops as well. If you've used other programming languages, you've likely used some of the other ones as well. Essentially, it just repeats a certain section of code as many times as you need or as many times as you want, depending on certain situations. The two most common kinds of loops that you're going to actually use are while loops and for loops. We'll talk about for loops essentially next Thursday after our review and our first exam. But today is while loops and sort of their close cousin, do while loops. So those are the two that we're going to mention today. So the while loop is used in Java and pretty much every language. I don't think I've seen a usage of a while loop that differs in some other language. You're going to execute a bunch of statements, whatever they might be, whatever code you might need to execute. You're going to do that while some condition is true. Now that might sound familiar. We just did if-else statements where we had if some condition is true, do something. So while is very similar. While a condition is true, run something. The nice thing about some of the terminology here is that it's relatively easy to read out loud to understand what's happening. So I'll show you the generic form in just a second, but I wanted to show you a concrete example first. So we've got some variable here. It's an integer set to a value of 1. And then we have the while loop. So we always start with while. That's one of the special keywords. We have parentheses, and then we have our condition. This is the exact same kind of condition you use in an if statement. So I can literally just read this out. I can say while iteration is less than or equal to 100. So that I can check, all right, iteration is 1. Is that less than or equal to 100? Yes. And so I execute the lines that I have between the curly brackets after the while. So this stuff in here, repeat this line, so it'll print that out, and then it changes the value of iteration. So iteration is 1, so we do the right side of our equation first. So we have 1 plus 1 gives us 2, set that to iteration. So now iteration is 2. After we finish the lines in the while loop, then we go back to the top and we check again. So we have 2 is less than or equal to 100. We repeat the line and continue doing this over and over until the condition in the parentheses is false. So the nice thing about a lot of the keywords and stuff here for our structures is that it is relatively easy to read out loud. While iteration is less than or equal to 100. So that Boolean expression, that's the thing that you want to pay attention to. That's going to determine how many times the while loop, the contents of the while loop, are repeated. The other important aspect here is that we are changing iteration every single time we go through the contents of the loop. So we'll talk more about infinite loops in just a little bit. So here's the general look of a while loop. So it's while, some Boolean expression in parentheses, and then open, close curly bracket, and then any statements you want. And in here, these statements can be a calculation, they can be a set of if statements, they can be other function calls, they can be pretty much anything we've seen so far. So in here, you may have some other conditions, you may have other loops, you may have other pieces of code that potentially can get quite complicated. So that's something that you'll have to sort of determine based on the kind of code you're writing, what you want to actually accomplish. The loop body, so terminology here, the loop body is what it is between the two curly brackets. So if I mention something like, oh yeah, in the body of the loop, that would be here. That would be the statements between the curly brackets after the while loop. So again, the body executes over and over again as long as that expression is true, and that Boolean expression is the same type we've messed around with for the if and sort of else if statements. Each repetition of that loop is called an iteration. So if I go through this loop 100 times before it stops, that would be 100 iterations. And I could talk about any individual iteration as well. I could say on the 10th iteration, it does this. It looks like this. The calculation equals whatever it happens to be. So when you hear me talk about loop body and iteration, that's the terminology that you typically assign to things like while loops and for loops and some of the other loops that we'll see later on. I want to do a very concrete example. I have two of these where it sort of shows the progress through the loop. So I have my little arrow here. It starts out, and it'll sort of show how this loop actually functions and where the code's actually executing. If you were to do some of the debugging stuff that we did last time, you would see that as you stepped through the loop using the debugger, it would do the same sort of thing. It would highlight the same lines that I'm pointing the arrow to here. So I'm just going to start here at the top. We've got an integer I. It's not assigned to anything yet. So down here at the bottom, I just say current value of I is just a question mark. I'm going to do a print. So the console output is over here in the blue panel. So I'll say enter I, and let's say the user enters 7. So this is just like what you would see on one of the homework assignment PDFs or something. Enter I type in a 7, and I press enter. So then we go into the loop. So we see this while, we say while I is greater than 0. So is that true? Yes. I is 7. So we go into our loop. We print the first line. This just prints out the value I. So the %d prints out an int. I is an int, so that currently is the value of 7. So we get a 7 printed to the console. Now we run the second line in our loop, and that changes the value of I. So we have 7 divided by 2. That's an integer division because I is an int, 2 is an int. So that's 3.5 if you were doing this in math class, but we chop off the decimal place because it's an integer division, so we just get a value of 3. So now I is 3. At this point, because we're at the end of the loop, this is when we check the condition again. So we say, okay, while I is greater than 0. Is I still greater than 0? Yes, it's 3. So we're going to run the loop again, print out that 3, print out I, and then change I again. 3 divided by 2 is 1, integer division. Is it still greater than 0? Yes. So we print again. We got a 1. Now we got 1/2. 1 divided by 2. That's 0, integer division. Now the while condition is false. Is 0 greater than 0? No. It's equal to 0, but we don't have the equal in here. So this is now false. So we don't run the loop again, and we just go to the end. So if you were running, again, if you were running this in the debugger, you'd see the exact same lines highlighted with this, and this is the exact output you would get. So every time you reach the end of the while loop, that's when you check the condition again and determine if it's true or false. If it's true, you run the loop again. If it's false, you skip the rest of the loop and continue on in the code. That's the basic function of the while loop. I have another one. This was a little bit more complicated. Let's see. So I have a question from Josh. So is it would it be infinite if a double was used? So let's say I did have a double here. Let's say I was a double and I read in a double. So in that case, I would always have some kind of fraction here. Even if I got really small, it would always be that small thing divided by 2. So I would never actually have a value that got to 0. At least it shouldn't ever get below 0. There is rounding stuff that happens way out in the 14, 15, 16 decimal place. It shouldn't ever go below 0 mathematically, depending on the rounding that takes place. May end up you may end up getting something that reports 0 exactly. So potentially it would end up as an infinite loop. But again, it depends on some of the rounding that happens with floating point calculations and stuff. But yes, Josh, you were on the right track there with changing this to a double might cause an issue. Okay, so I do have another one. This one has a couple of variables. And it's a little bit more complicated as to what happens here. So it's important to keep track of I and sum. We have two variables, I and sum. I starts at 1, sum starts at 0. And then again, we have the console output over here on the right. So we're going to start with while I is less than or equal to 4. Okay, so current value of I is 1. So that works. We're going to go into the loop. We're going to take sum, and we're going to set it equal to sum plus I. So sum was 0. We add I to it. I was 1. So sum now becomes 1. Then I'm going to increase the value of I. So on the right-hand side, we have 1 plus 1 gives us 2. So now I is equal to 2. We're at the end of the loop. So let's check the condition again. I is less than or equal to 4. Is that true? Yes. So we run through this calculation again. Sum now becomes 3 because we had 1 and we added 2 to it. I was 2. And then we increase the value of I by 1, and then we check the condition again. Is 3 less than or equal to 4? Yes. So we run again. Sum was 3. We're adding I to it, which is another 3. So we get 6. I increases to 4. Is 4 less than or equal to 4? Yes, it is equal to. So that does count. So we run this again, and we get 6 plus 4 gives us our 10. I goes up to 5. Now we have a false condition in our while loop, and we skip the rest of the loop, because we have false here now, and we print out the sum, which was 10. So this one, it's a little bit more complicated. It's the same process, but we have to make sure to keep track of what each of these variables are during the course of the loop if we want to make sure we get the right value at the end. If you're writing a complicated loop and you're not quite sure just by sort of the code that you write or the code that you might think you need to write for a particular loop, it can be worth doing something like this. It can be worth just sort of writing out a few iterations. So here we did a few iterations. We kept track of the values during those iterations. It can be useful to just to check to make sure it's what you expect. I do this quite often if I'm sort of coding something up and I'm like, wait a second, I'm not sure if this is exactly doing what I want it to do. I think it should, but it might not be. So then I will go back and maybe write down a couple things, or you could potentially throw it into the debugger as well to see what the values actually are and if they are what you expect. So the idea here, same as the simple version we did, just keeping track of a couple more variables here than we had in the previous one. So that's the basic sort of idea of the while loop. Does anyone have any other questions before we keep going with this process of loop iterations and checking these conditions? Okay. So let's talk about some of the code that you saw in there. So we had this I equals I plus 1. This is perfectly valid. Remember that the equals is not like a math equation equals. It's not like a statement of fact. It's an assignment. So the equals is an assignment operator. So you always do the right-hand side stuff first, and you assign it to whatever's on the left-hand side. So to update I, to increase its value by 1 for the next loop iteration, for instance, this works perfectly fine. It'll take whatever the current value is, add 1 to it, and overwrite whatever used to be in I. So remember that this sort of I equals I plus 1 is essentially overwriting the original I with whatever's calculated on the right-hand side. So the quick example here, if I is currently 3, then it's going to plug 3 into the right-hand side, set it to 1, or add 1 to it, and then assign 4 back to I. So just a little concrete example there. The same is true for doing this for basically anything. So sum equals sum plus, in this case, I, which was in our previous example. It would just add I to sum and then save it. There's some shorthands for that, and I'm going to show you here in just a second. All right, so when a program reaches a loop for the first time, it's always going to check that condition, that initial condition that it has in the parentheses. If it's true, the body begins to run. When the last statement executes, the program goes back and checks the original while line. So it's never in between. The condition is only checked at the beginning when you first hit the while loop and after the end of the last statement in the while loop, not after every single statement. So you don't have to check every single time, at the beginning and when you reach the end of the while loop during each iteration. So all of the code within your loop body is guaranteed to run if the condition was true. All right, so I'm going to go into Eclipse, and we're going to do a quick little exercise. I'll sort of talk about sort of the way that I approach this sort of thing. So we're going to write a program that prints out all the numbers from 0 to n, including n, and n is going to be provided by the user, or provided by the user. So we're going to ask them for a number, print out all the numbers, and then we'll put each of them on their own line. It doesn't really matter sort of have the format of printing it out, but we'll put each of them on their own line. And we're going to use a while loop to do this. So if I go over to Eclipse, I've got just that sort of basic sort of standard Java file ready to go. I have the scanner already written in, which means I have the import line as well. So I'm ready to do some input stuff. So I'm going to start with just system out printf, and we're just going to say enter n. Now, I don't need anything else here. I don't need any of the sort of comma args or any of that because I'm not printing out any values here. I'm just asking them for the particular number. Then I'll create a variable called n, and I'll set that equal to input.nextInt. So this will have me read in the value from the user and save it into n. All right. I'm going to create one more variable, and you'll see why here in just a second. I'm going to call this variable I, and I'm just going to set it to 0. And then we'll put our while loop in. Typically, when I'm using some of these structures like if-else and while and for, when we get to that next week, I'll just start by outlining it. So Eclipse helps me a little bit by putting in some of the sort of ending bracket stuff. But this way I know that, all right, this is my while loop. I need to put a Boolean in here, and any statements I want to run go in between my brackets. So we're going to use I as our counter. How many times have we actually run this while loop? This is a common theme inside of any loop. How many times has it actually executed? It's worth knowing how many times it's executed in most situations. So I'm going to say while I is less than or equal to n, then I'm going to run this. So the first thing I'll do is print out the actual number. And one of the things you'll notice is that I'm going to use I for the print as well. So we're going to print out I. And we'll think about exactly why in just a second, after we write the next line. Now, I need I to change because that's essentially our condition. So I need I to change every single iteration. Otherwise, I'll end up with an infinite loop, which is the next slide on the which is the next slide on the presentation. So I'm going to say I equals I plus 1. So I goes up every time. So eventually, this condition will be false. Eventually, I will be greater than n. Because I'm printing I, and I started at 0, I'm going to print 0 first, because I'll have 0 less than or equal to n, likely true unless I enter in a negative number. I'll print out 0, and then I goes up by 1. And then I'll check the condition, and I'll print out 1. And I'll have this go to 2. And I'll check the condition, and I'll print out 2. So I'm using I as our counter and as the value that I'm printing, because essentially I'm just printing out the number of times I've run the loop. So if I were to run this, and I type in, say, 7, there's my 0 to 7. I want you to think about what I ends up being at the end. If I print out I at the end, if I print out I here, I'll type in after loop, and I'll print I and a new line. So I'm printing out after the loop. Let's put in that 7 again. After the loop, notice that I is 8. Because I printed out 7, and I increased the value of I to 8. and then I checked, is 8 less than or equal to 7? No. I moved on to the rest of the program. So the way that I go about sort of analyzing this style of loop is to put my little outline first, put my parentheses, my brackets, and then I start thinking about, all right, what do I want to print out? How do I go about ensuring, for one, that this is going to be false at some point? I got to increase I every single time it runs. And then in this case, I had to think about, what am I going to print? I can't print n because that's just a single value. I need to print something that is counting up from 0. And in this case, that was I. So even though this is a relatively simple loop, the structure of this loop will likely be similar for many loops that you end up writing. There's some kind of condition, there's some kind of counter-like variable, and you're increasing that counter so that the condition will eventually be false. That's the idea here. All right, any questions on that one at the moment? So we're going to come back to this in just a second. The potential answers here is basically what I had written. All right, infinite loops. You always want to be careful to ensure that your loop conditions will be false. There are some exceptions to that. Just like with most programming things, there's exceptions where you might want to do things slightly differently. But for the most part, you want to make sure your loop conditions are false. Loops that have conditions that are always true are infinite loops. Usually they're a mistake. Not always, but usually usually it's a mistake that you've made, that you've forgotten to make sure the condition would be false. If you get stuck in an infinite loop, and I'm going to show you this in just a second, you want to make sure to terminate your the actual run that's currently happening. Even if nothing's printed to the console, it could still be running. So that would be the terminate button, the little red square in the console window. So something like this down here saying iteration equals 1, while iteration is less than 100, then you print a line. Well, iteration never changes in the loop. So iteration will always be 1, which means this condition is always true, which means this just prints forever until you stop the program. So back to our code here. If I comment out my increment for I, then I've created an infinite loop. This condition will never be false. So if I run this, save it. If I run this, it's just going to print 0 forever. And it's continuing to go. This is continuing. This is continuing to print 0. And it'll keep printing 0 until I stop the program or turn the computer off or something. Over in the console window, right over here, and we talked about this a little bit with the debugging, right over here, there's the little red box. That's the stop button. So if your program's running, you want to press that if it's stuck in an infinite loop or something. Even if you don't print to the console, so if I don't print anything here, this is still an infinite loop after we go into the while loop. So it's still running right now. It's just running through this loop really fast because there's no code in there. But it is still running because I can see that the little red box is still lit up. If we were in class right now, if we were like all together in a classroom, this would probably be a little bit more important. Typically, if you accidentally create an infinite loop on whatever laptop on whatever laptop you would be using in class, you'll eventually hear the fans start to spin up, and then your battery will start to drop. Especially if you don't cancel the run and then start running other stuff. Java will be taking up more and more of your processor as you run more and more executions of your code that has an infinite loop in it. So you do want to be careful with that. If you are just on battery power, make sure before you start running stuff again, make sure that you've canceled any previous runs if something didn't seem to work correctly. That happens sort of more often than you think. I even the first semester I did my sort of auto grading stuff with some scripts that I had. I didn't put in a check if there was an infinite loop in the in students' code, and so I had noticed that, wow, this grading's taking way longer than usual. The script's taking really long to run, and then I noticed the battery on the laptop I was running it on was starting to drop, and and this fan was starting to spin up. So I had to add in a bunch of extra code to make sure that it caught infinite loops that were happening in students' code. So it does happen. It's likely not intentional. Just keep in mind that you want the condition to be false. You can actually just put, if you want, you can actually just put something like this. This is also an infinite loop, but Eclipse is gonna warn you. It's gonna say unreachable code. So if you ever see something that says unreachable code, then Eclipse is able to determine that, hey, this you've just created an infinite loop. So sometimes it can figure it out, but most of the time it's not. So that's something that you do want to keep in mind as well. That Eclipse can catch it, but it's not always going to do it. Not always going to catch if there's an issue. All right, so keep that when you're using loops, just sort of keep that in the back of your mind. Infinite loops typically are not something that you want. Now there's some shorthand for doing that increment part, that thing where I have the I equals I plus 1. So Java and a lot of other languages do include a shorthand increment and decrement operator. So these are useful with loops. They're useful for other stuff too, but for the most part, you're probably going to use these with loops. So the increment operator is just plus plus. So if I just put count plus plus and a semicolon, that's literally the same thing as me writing count equals count plus 1. There is a difference putting it in front of or after the count. For now, just think of it this way. Later on, we'll talk about the difference between putting it in front or behind. It's based on when the value actually gets changed. There's also a decrement operator, so it reduces a value by 1. That's minus minus. So I minus minus is exactly the same as me writing I equals I minus 1. So just a little bit less code to write. So you don't have to write the equals and then this variable again and then the plus 1. Not all languages have this, but most C-like languages do. So it is quite useful, and you will likely be using this quite a bit in your loops. So that's pretty much it, sort of a basic while loop. We will do sort of more examples with loops and stuff like that, but I want to mention the sort of close cousin of the while loop. This is the do while loop. So if you make a while loop where the condition is false initially, so if I go back to the code here, let's go back to where we were before, and let's say I set I to be 10. So if I run this and I put in 7, it just never does that loop. I immediately print out the thing that says after a loop. So it totally skipped it. Because when we got to the loop line, I was already greater than n. Greater than or equal to n. Or in this case, strictly greater than. So it never ran those lines. The do while loop allows us to change that behavior slightly. So if the condition's false when we reach the while loop, it never executes. If you want the code in the while loop to execute at least one time, then you use a do while loop. So something like this, and I'll show you the generic form here in just a second. But it'll look like this. So I have this integer here, it's called input value. And then I have a do, just a do, and the curly brackets. And notice the while is at the end. So it's the same sort of structure for the while. I have the while, and then I have parentheses and a Boolean statement. But it's now at the end of the curly brackets. And I have a semicolon here as well. So this code, the 2 lines I have in here, are guaranteed to run at least one time. So here it says enter 1 to print this message again. And then I have the user enter in an integer. If they enter 1, so I'm going to do this stuff while input value equals 1. So if I enter a 1, it will run again. If I enter anything else, it'll hit this condition, it'll be false, and the code will continue. So the do while guarantees the code's going to be run in your loop at least once. This can be useful for things like user input, just like this. If I want to guarantee that the user can enter something and then check what they entered to see if it was sort of, in this case, just to print the message again, then a do while loop is what I'm going to need to do. So here's the basic structure. It's just a do, curly brackets, any of the statements you want, similar to the while loop, whatever statements you want to put in there, and then a while Boolean expression. The thing that is easy to forget is the semicolon. You do have to have a semicolon here with the do while. With the regular while loop, there is none. But with the do while, there is at the very end there. Yeah, so that's something that I do have in text here. All right, this goes along directly with sanitizing input. I mentioned these with garbage in, garbage out stuff last week. If I get some garbage in from the user, likely either my program's going to crash or I'm going to get some sort of weird value or wrong value, garbage value back out. So this, I think, is actually a pretty good example of that, of trying to sanitize your input. So it's a do while. It says enter a positive number. So I allow the user to enter whatever number they want. And then I check, is that number actually positive or 0? If it is, then I'm going to run this math calculation, get the square root. If it's not, if it's negative, then I'm going to ask him again. That ensures that I have a positive number when I get to this region to do the square root, because I don't want to have a square, I don't want to do a square root of a negative number. So that's what I mean by this input sanitization, making sure that I have a value that makes sense for whatever my code needs to do with it, in this case, a square root. So the do while loops are going to be useful for that. Is this better than using an if? Probably. It partially depends. If we use an if statement to do our sanitization, we would check if the number is negative, then we'll print an error message. And then we'd have to exit the program because we don't want to run the actual square root. Is it better? Is this a better way to do it? Maybe. Maybe not. It depends on the situation. But this is one of the ways that you can do your input sanitization. Here's another one. This one is with strings. So enter Y to print this message again. Remember, input.next is how we read in a string. If the user enters Y, so while the input value dot equals, remember with strings, we don't use equals equals. With strings, we use dot equals. So if whatever they entered equals Y, then we print the message again. Otherwise, we continue on. Is this better than an if statement? Yeah, we wouldn't be able to do this easily with an if statement, and certainly not an infinite amount of times. So this one definitely going to be mostly, you're going to mostly want to use a do while to do this sort of thing. For the input sanitization that we did with the square root, it depends on what you want to do. Do you want to exit the program, or do you want to allow the user to enter a value again? So the do while, very, very useful. All right, so I have one more exercise for now, and then basically the while loop stuff we'll sort of wrap it up. So we're going to write a program that uses a do while to read integer values from the user until the value between 1 and 100, and we're going to include 100 in that, is entered. So essentially, we want to make sure, let's say we were asking for a guess or something. We wanted the user to guess something between 1 and 100. We want to make sure they actually type in something between 1 and 100. So we're going to use a do while loop to do that. So back in my code here, I'm going to delete the stuff we had before, and I'll say enter a enter an int between 1 and 100. So that's going to be my sort of entry stuff, the request. And I'm going to say int, I'm going to create an int called input value. And this is going to be input dot next int. I'm going to show you a common issue that comes up. That's why I wrote this piece first. I want to make sure they enter a value between 1 and 100. If they don't enter a value between 1 and 100, I'm just going to ask them again. So that's the whole point of using the do while here. So I'll start with the do, and I'll put my bracket. And I'm going to put this stuff in between. So I have stuff here. And I'm going to say while. And I don't want to forget the semicolon at the end. So I sort of have my outline. Yeah, I already put a couple lines in here, but that's because I had already written them. And then I'll put my condition in. This needs one of those combined expressions, because I want to make sure that I'm going to ask this question again if the input value is less than 1 or greater than 100. I have sort of two conditions I need to make sure to satisfy. Sometimes you have to think sort of backwards in this. Think about what needs to be false for this to run again. So sometimes you got to sort of flip around sort of how you're thinking about it. I want a number between 1 and 100, which means the while loop, that needs to be opposite. So I'm going to say input value. I need the input value. If the input value is less than 1, or, remember or, so the double pipe or the double bar, input value greater than 100. So this will continue to run. It will run again if the input value is less than 1 or greater than 100. Now, notice that input value has one of the red squiggles under it. It's an error. And the error says, I know it's a little bit small, but the error says input value cannot be resolved to a variable. It doesn't know what input value is. Now, in the near future, we're going to talk about a concept called scope. For now, know that I've declared input value inside of the do loop, inside of the body here, the do part of this. The while part of this cannot see that value. So this stuff in the parentheses here cannot see that input value exists. Now, again, this is the concept of scope, and we're not going to talk about it until probably after the for loop stuff to get a better handle on it, but you will see potential issues like this. So in order for this to work properly, I need to take my declaration saying that input value exists. I need to take this outside of the loop and delete the int from inside the loop. So now I've said input value exists. I'm going to use it in the loop, and then it works fine here. So that's something to keep in mind. Anything that you declare inside of the loop body, you can't use it outside the loop body. So keep that in mind when you're messing around with some of these loops. And we will come back and we'll talk more about that. So enter an int between 1 and 100. Let's say I put in 0. It just asks me again. I put in 101, asks me again. I put in a 6, and it finishes. So that's a more complicated sort of if, do this while this condition. It's a more complicated condition, but it gives us that range of less than 1 or greater than 100. So that's something to think about when you're using these while conditions, that you can have much more complicated while conditions. And of course, it's worth checking those edge cases. Does 0 work? Does 1 work? Does 2 work, for instance? 99, 100, 101, do they work the way that you expect? So same sort of debugging type stuff that we talked about with if statements as well. All right, so is there any questions on this do while loop? If I remember correctly, I think PA3 is loop stuff. You're not going to have a PA this week, so you don't have to worry about it for having something due a couple days after the first exam, but we'll get back to doing that stuff the Thursday after the exam. So you will have another assignment assigned next week, but not this week. So potentially if you want to study over the weekend, you can definitely do that. So the next assignment will be dealing with loop stuff, if I remember correctly. All right, so here is a sort of potential solution to that. Notice again that I've declared the variable outside of the loop and then just used it in the loop. That's a sort of a very common issue that folks can forget. All right, so the take home when it comes to these loops is that the while loop is used to repeat a series of statements as long as that condition in the parentheses is true. The do while is a close cousin. It just guarantees that loop body, the statements you put in between the brackets, they're going to run at least once. and then the condition gets checked. Watch out for infinite loops. They're very easy to create on accident. And then start thinking about using the increment and decrement operators as shorthands to subtract, say, 1 from a variable. Okay, so that is all I have for today. So exam 1 review is next time. PA2 is due Thursday at the end of the day, so make sure that you are working on that. Again, I have my office hours after class. I'll probably we're done a bit early, so I'll probably get a drink and stuff. But make sure that you either come by my office hours or go to the tutoring session if you have any issues. Otherwise, have a good rest of your day, and I will see you on Thursday.
Thank you, Professor.
See ya.
Thank you, Professor.
Thank you, Professor.
Thank you, Professor.